Hello everyone, my name is Ashfaq Ahmed and I work in the field of structural biology and bioinformatics. Welcome to Python for Biological Data Analysis. Today we are going to cover chapter 2 and its name is Complex Structures. Before this we have already covered chapter 1 that was a kind of foundation for Python, where we discuss different data types and different variables and how to use different uh, functions. And that was pretty much basic. So today we are going to a little bit advanced level, not so much, but little bit. So thank you for being with me and for liking my videos. So let's start. Yes. Okay. As usual, you have to open your web browser and type Google Colab, and you need to click here. Welcome to Colab. Now you will see this window. Click GitHub and type ASH100. Enter. Once you have this window, click here and scroll down to Python for Life Sciences. Here you can see chapter 2, control structures. Click here. Okay, so now you are here. Learn Python for biological data analysis, chapter 2, control structures. Now it's good you need to click this connect button. Your notebook will be connected. As usual, you will be greeted with the course content. We have covered this chapter and you can find it on the channel website or the channel pages. Now, today we will cover control structures, and here we will discuss some basic functions, some loops, and a little bit we will bring a little bit advancements. Okay, so now scroll down. Okay, so once again, welcome to chapter 2, control structure. In this chapter, we will learn how we can use Python to make decisions. So Python is not like a human to think. We will ask, we will use certain words, we will use certain functions so that the Python can make different decisions for us. Decisions in the form of it can classify organism based on characteristics. It can analyze multiple experimental samples. It can process large data sets efficiently, and it can automate repetitive lab calculations and create reusable analysis tools. Also, you can achieve much more from Python. So today we will discuss how we will be able to use Python for decision making. And the chapter name is control structures. Okay, so section 1, uh, conditional statements or making decision, we will talk about. So there are three statements you need to understand: if, elif, and else. If, else, and elif. Elif is actually the combination of if and else, something like that. So what is if? It's simply just like in English we are using F. So it's almost similar. If we use this statement, if, then that means that runs the block if the conditions are true. We will learn how what I mean from the condition if they are true or false. Yesterday we discussed about like what are true and false. The true and false are the Boolean data types. Okay. So if the condition is true, so run this particular statement, otherwise not. Else runs the block if none of the above conditions are true. And elif or else if runs the previous condition were false and this one is true. So I'm sure you will not able to understand this. So let's understand these statements with examples. Okay, basic if statement. So I made a variable, let's say temperature is equal to 37. Yesterday we learned how to make a variable, so that's why um, I will not go into that discussion again, like what are variables and what are different data types, etc. So the temperature variable is 37. Now I use the if statement and I ask if temperature, use the same spell like this variable, if temperature is greater, or let me make it bigger with the screen, it will be maybe more okay. Okay. If the temperature is greater or equal to 35, then print optimal temperature for mesophilic bacteria. Let's run this code. Okay, it prints optimal. Let's run it again. Optimal temperature for mesophilic bacteria. Let's, okay, our condition was if the temperature is greater or equal to 35. Let's say I'm making it 30. What it will say? It say nothing because we ask Python to decide or to print this statement if it is greater than 35 or equal to 35. Let me make it 35. Optimal temperature is 35. Now, coming back, what we said runs the block if the condition is true. So the condition was if the temperature is greater than 35. Okay, let's move on. Example 2. pH, we have a variable pH underscore level or pH level. Why we are using underscore? Yesterday we discussed that in variable we cannot, it cannot be start with a digit or it cannot have a space, so that's why. So pH level is equal to 6.2. Now we are using if statement three times. If pH level is equal to 7, print neutral pH. If pH level is 7, greater than 7, print basic slash alkaline pH, or if pH level is less than 7, then print acidic pH. Let's run it. It says acidic pH because it is 6.2. Let's say I'm making it 9.2. Now it has printed like basic or alkaline pH. So that's how we can use the if statement and to make a decision in big data or kind of classification in big data, whatever you can use it. Okay, so this you can use this for as yourself. So let's say okay, now uh this is if else statement or elif statement. What we discuss about the elif statement or else if statement runs if the previous condition were false and this one is true. So what does it mean? Okay. For example, we have a variable glucose level that is 120. Okay, and this is a comment we discussed yesterday. Mg into dl. Okay. So 120 is a glucose level. Now we use the first condition is If glucose level is greater than 100, print high glucose level, diabetes risk. But if this one is wrong, if you read here, if the previous conditions were wrong or were false, then print or run the other condition. Okay, so if glucose level is greater than 100, this is condition 1, print high glucose level, diabetes risk. Else print normal glucose level. So here we say 120, so it says glucose level is high and diabetes risk. Let's say I'm making it 90. What will it say? It's a normal glucose level. So here we use uh, two conditions, if and else. Now, once again, from biology, from molecular biology, we have two variables. This is wild type sequence, this one, and the other one is control sequence, or I name it sample sequence. So this is the wild type sequence and this is the sample sequence. If sample sequence is equal to wild type sequence, print no mutation detected. But but if there is mutation, then use this condition or print mutation detected. So we are going to run it. It says no mutation detected. Let's say I'm bringing a mutation and in the sample sequence I'm changing this C to T. Now what will it say? Mutation detected, because the if statement is now true, so the else will not work. But if the if is false, then the else will be printed. You got my point? Okay. Now you can run this one by yourselves. Now we are moving towards the another elif statement with multiple conditions. Okay. If okay, the variable is environment temperature 15. If environment temperature is less than 0, then print this one. Psychrophilic conditions, or the environment is less than 20, then mesophilic. If the environmental conditions are less or smaller than 45, then thermophilic. But if all of them are wrong, then use the else and hyperthermophilic. So just run it. You will say mesophilic condition or moderate temperature, the second one. But let me change it to, let's say, 50. It says hyperthermophilic conditions or extreme heat. So you are observing like how Python is making decisions on your statements, and these are simple statements. Yesterday we learned this, or we also learned the print statement. Now today what we learned, we are learning, we are just using the same name, this, with some condition equal to or not or greater or less than this number, and then stopped by a colon, and using this if statement or elif statement, and it will decide for you. Okay. Now, this is the BMI condition. You can run these two conditions by, one is the enzymatic activity and other one is the BMI classification, body mass index. Okay. Now we are coming towards another section that is called comparison operators. So how, if you are comparing something in Python, then what operators you will use? So this is the equal to, this is the not equal to. In Python, you will write this exclamation or bang symbol followed by is equal to or equal symbol, and that will be not equal to, greater than, less than, greater than or equal to, and less than or equal to. I think it will be easy for you to understand. Okay, now let's say we have a sample size, let's say 30, and we have a control size, let's say 25. Now we are using some different statements here. The first one, print, and yesterday we mentioned that the if sign is for formatting, so you can use it. So print, and this statement, which is uh, in different color, it is actually we want to print. Okay, because it has a space, and here we cannot use a space, so that's why. And in the curly brackets we will enclose, yesterday we learned in the curly brackets we will enclose this variable, let's say. So print if statement, and then the word we want to include, and then in curly bracket the sample size, comma, then we want to include the control size word, and then in curly brackets again comma, and the whole statement is closed in inverted commas and parenthesis. So similarly, if you see, I can use all these things like equal to, not equal to, greater than, all these things we discuss here. So let's play it. Now it decides different comparison. It compare different things in manner of booleans like false, true, true, false, true, and true, true and false. Okay, now we are coming towards logical operators. What are logical operators and how you will use them? Python use different logical operators and their combinations. So you need to understand first, because I'm in my focus or in my mind, you all are the students of biology. So that's why you need to understand there are three basic logical operators: and, or, not. Okay, so how we will use and, or not? For and, it means true if both conditions are true. For example, we are saying like Ali and David both are male. So in this case, both the variables Ali and David both are male. Let's take it this way. So the AND operator, it works. Okay, we will learn it while using. Okay. Let's say temperature variable 37, pH variable 7.4, and oxygen variable 0.2. Now you are aware of else, if, and elif statement. So if temperature is greater than 35, you see we are using two different things. If temperature is greater or equal to 35 and pH is greater or equal to 7, and oxygen is greater or equal to 0.15, then what you need to print? You need to print optimal condition for cell culture. Otherwise, if any one of them is not true, else then you have to print suboptimal conditions. Okay. Now, okay, let's say this is for, let me run it. Okay. Can you see optimal condition for cell culture? And in the second case, I ran all the three example in one. In the second case, we has fever, true, has cough, true, has headache, true. If has fever or has cough or has headache is true, then print patient shows symptoms, further evaluation needed. If any one of them, okay, this one is false. If any one of them is different, then show no symptoms detected. So you can also generate your own statements here. Yesterday I showed you. Let's say you want to try some example here. So just bring your mouse here, click code, and you can write your things here. It will be a good practice for you. Okay, now we are coming to section 2, loops or repeating actions. Actually, sometime we want different repeats or different actions which needs a repeat of the program to study or to read this. Let's say a biological sequence, we want to run it and calculate something else at this point. Now we want to run it again and calculate something else at this point, and that we also want the same program to run it for the third time and calculate a different thing. Sorry for disturbance. I had some disturbance here, so that's why I pause it. Okay, so we were talking about loops. So we have for loops and while loops. Repeat a fixed number of times or over a sequence, or repeat while a condition is true. So let's say we are coming directly to the example. Let's say we have a variable sample IDs, then you can see like this is the first variable, sample IDs, something. Okay, print processing samples for sample in sample IDs, print f analyzing sample. Okay, so now you can see what we were trying to do. We were asking we were asking this to read, or you can say like this, that the command has read this many times because it has many multiple samples, so it analyze this because we asked them to analyze sample, print the analyze sample and in sample. Okay, and what we use for, so we discuss here, like one is for loop, one is while while loop. So here we use a for loop for samples in sample IDs. So if there are right now we had 5 samples here. Let's say we have 10, 20, 40. So each time it will extract a single sample from your variable and it will mention it here. Okay, the same way we can apply the for loop on the DNA sequence. Let's say this is our DNA sequence, a variable, and then we say that print analyzing sequence. This is the DNA sequence in the curly brackets is actually the variable. Okay, for I is actually the position of each nucleotide in this sequence. So for I nucleotide in enumerate DNA sequence, print position I and nucleotide. Let's say what it does. So for each and every position, it enumerate uh, the whole sequence and print it like this. But if you see, the enumerate it's a kind of, it's in a different color. So the enumerate is a function. Yesterday we talked about what are functions, and I told you that there are many built-in functions like len, that calculates the length of that variable, whatever, if it is a sequence. Or we also talked about the print function, and now here we use enumerate uh, function. Okay, so you can try this by yourself. Now we are coming for a range function. Function range, it's creating number sequences. The range function is used to generate a sequence of numbers. It is commonly used in loops, especially for loops. So how let's try this example. Let's say we are asking, we do not have any variable, but we are asking print day 1 to day 5 of experiment. For here is a loop. Why it's a loop? Because we provide a range from day 1 to day 5, like 5 days. So it will print day 1, then day 2, again come back day 3, day 4, day 5. So this is a kind of loop. So print day 1 to day 5 of experiment for day 1 in range 1 to 6, print day and day record observation. Because we did not use any what to say variable in this, so it just print day 1, day 2, day 3, and day up to day 5, and we asked to just print record observation, and they just printed the record observation. Similarly, you can apply these two by yourself, because I'm also taking care of the video time. Now, the third thing is the while loop. We discussed for loop just before. Now we are going to discuss the while loop. Okay, the while loop are actually doing the same thing like for loops we did, but in while loop we we will use the while if there is some condition with it, if we are using some condition. Let's say bacterial count 100, generation 0, these two are our variable, and then we will say print bacterial growth simulation while. Now this is a condition, while bacterial count is smaller than 10,000, and this is the generation. Generation means equal to 1 or plus 1, like go one step forward. And for bacterial count, you have to multiply by 2, it means doubled. 2 to 4. Let's say in biology we are saying like this, like every 20 minutes the bacterial populations become doubled. If it's 2, it will become 4. So here we offered a bacterial count 100, so just go from here. So these are our conditions, and then we ask like print, this is our own word generation, and this is the in curly brackets, this is this generations from 0, start from 0. In this curly bracket, this variable bacterial count, and then type bacteria. So let's say, okay, generation 1, 200 bacteria. You see, we started from 100, but in generation 1, let's say we will say like this, after 20 minutes these 100 will be doubled into 200, but the 200 will be then in generation 2, after 40 minutes 400, like this. So in generation 7 they will reach to this 2000 12,800 bacteria in generation 7. So there was a clear difference between for loop and while loop. In for loop, we did not use any condition, but in while loop, we will use certain condition. You can also run this cell by yourself. This is another example. Okay, loop control, break and continue. So can we break the loop, or can we control this loop with certain breaks or continue? So let's start with this example. Example 1, finding first occurrence with break. Okay, here this is just example, not for this. This is the example of this. These just kind of three lines theory, like how we can use, for example, if you want to stop the sequence at certain the code at certain level of the sequence, so we can. But here uh, example 1, finding first occurrence with break. For example, we have a DNA sequence, this one. Now we are searching for start codon. Then this is we explain the start codon with this variable. Now we will print searching for start codon, and then this is a curly, in curly loop we mention the variable, uh, start codon, search for this in this variable, which is a DNA sequence we provided. For I is a position in range. Here we use two different functions, the range functions and the length functions. So for I in range length, DNA sequence -2. Okay, that means that you need to calculate, uh, how to explain it. Okay, you will understand from this codon, I hope, hopefully. Okay, codon is equal to DNA sequence. This is the codon. The DNA sequence is our variable. Here is our variable, and I plus 3. Okay, if codon is equal to start codon, then print this statement and then break. And if you find the start codon, then break. So here we are asking the code where to break. So let's say I run it and it says searching for a start codon ATG in this, because we ask him to print like this, start codon not found. Let's say I'm using now ATG. I change the sequence and let's run it again. It says searching for the same sentence, but found start codon at position 7. So you can count it 1, 2, 3, 4, 5, 6, 1, 2, 3, 4, 5, 6, 7. Okay, it's count from this way. So you can see at position 1, 2, 3, 4, 5, 6. So that is not a problem. The 5 prime or 3 prime, it can be fixed. But here I just want to tell you like how you can use the trick option in Python. Okay. So coming to the point, this dash 2, because the codon is a triplet code, so here we are asking the program to read in 3. For example, this is our sequence. Let me put it like this. So it will read like this: a t c. Then in the second, oh wait, a t c. Then in the second it will read this TCA. This will be the second one, TCA at position 2, and then the third one will be CGA. So here we use this range option, like for like do not, uh, we call it indexing error. So do not comes to minus, it's not -2, it's actually -2. So do not come to 2, just try 3 3 3 3 like this. So I hope I convey the statements, or you can search yourself also using this code. Okay. Now, functions. What are functions? So, functions, as I told you yesterday also, these are the built-in strategies, built-in codes which are already present in Python. So, you will need just to use it. Like today, we use enumerate functions, we use the len function. Yesterday, also today, we use the range functions. So, there are many functions. Print is itself a function, so you can use these functions and you can further define these functions. So now we are coming to define the function. In definition, we actually uh, add or subtract, or if we want to extract something more from the function, then we use a definition. So let's come to this example. Let's say we have a function calculate underscore BMI, and we define this function like def definition are defined calculate underscore BMI, and it will be weight underscore kgs comma height underscore m, and then friend uh, calculate body mass index from weight and height. Okay, BMI will is equal to weight in kgs divided by height underscore m. This is our formula, and then we say return BMI. So we define the some values like we are doing in Excel, some formulas. Now we will use the function. So how? The patient weight will be 70. Let's say patient weight will height will be this, patient BMI, and then we use the function directly calculate BMI. But what is inside, or what the calculate BMI will do, it is already explained here in the definition. So calculate BMI on patient weight and patient height. Okay, so and finally print the patient BMI with this word. In this curly bracket we mention the patient BMI, and if you see dot 1 if, so that means that if the data is in the float means if there is a decimal point, so go for one decimal point. So let's say you can see 1222.9. Let's say I'm increasing this number 90, what it will print 29.4. But if I say it to 2, 29.39. So this world dot 1 if, that means, or if you say 0 is 29. Like if you are going to a float, so you have to mention up to how many decimal points you need the answer. If you print a percent, if you see a percent option here, that means that if the answer is in percentage, then you need to go to this point. Okay, now functions with some biological applications. I think you can do that by yourself. So I leave these things to you. Okay, now some functions with default parameters. For example, definition, the bacterial growth, initial count, growth rate this times in hour this, final count is equal to, now we are defining this, the final count is initial count multiply by the growth rate exponential into the times hours, and then you ask them to print with these words with default parameters. In default parameters you need to print bacterial growth, and in custom growth rate, and these are our variables in the curly brackets. Okay, so when we click them, or when we click it, you can have your answers. So because this is the bacterial growth is a default or a built-in function here, though you can define with certain other things you want to achieve from it, and functions that will retrieve multiple values, you can use these example by yourself, because I'm exceeding the time again up to 40 minutes. And now we are nested structures and complex examples. So nested loops for multiple nested structure and complex example. Okay, nested loops for multiple samples. Here, for example, we have many patients. So far, we were dealing with one patient. So let's say we have three patients and we have three variables we want to measure: the temperature, the blood pressure, and the heart rate for each patient. Okay, so now this is our print statement, and now we will use for, because we do not have any specific condition to use a while, so we use a for loop for patients in patients. Now prints patients in patients, for measurement in measurement, and recording measurement. That means that if you have some variables here, in this example we have three, so record all these three for each of them. For patient 1 these three, for patient 2 these, and for patient 3. Now coming to the functions with conditionals and loops. So okay, for example, we have a classify sequences. So we will provided some sequences, 1, 2, 3, 4. So these are our test sequences, or you can say kind of variables. So now we assign some conditions, like for I is a position. So enumerate each sequence in sequences for length and for GC content. Then classify if length is smaller than 10, tell them short, medium, long, and the GC content low, medium, high, and also the sequence length, GC size, and GC class. So let's run it. Okay, it generates an error like GC content is not defined, because we ask certain things for GC content in the code and here also, but if you see, we only defined the classify sequence, we did not. So I will fix this code here and define the GC content, and will you will not see this error. Now you can see for sequence classification results. Oh my God. Okay. Okay. So there are some practical exercises. You can run it, then you can. One is for antibiotic susceptibility. Another one is for GC content. This is for the DNA mutation. At least, and some homework if you are interested. At least after taking these sessions, I'm not claiming that you will be an expert, but at least in future, these classes will provide you a foundation stone, or in the future, if you see some error, so you will understand what are variables, what are floats, what are definitions, and once you have this background knowledge, so you can move slow and steady with me or from somewhere else, and these classes will help you in future for sure. So that's okay, or that's all for today. I hope you are enjoying these classes, and I'm sorry for because I'm trying to cut it short, but somehow I'm unable to complete these classes, each class in 30 minutes. So I'm sorry for that, and thank you so much for watching and for giving me your time. Thank you so much. Bye bye.